This is number 81. Title is Rhombus. A rhombus is a quadrilateral with all four sides congruent. A quadrilateral with all four sides congruent. So let me draw a rhombus for you. So this side is the same length as this side, is the same length as this side, is the same length as that side. So it's got four equal sides. That's called a rhombus. Okay, now back on note card 79. Oh, sorry, before I get to that. Is a square a rhombus? Yes, it is, because it has four equal sides. So any figure that has four equal sides is called a rhombus. So a square is just a special type of rhombus. This obviously is not a square, but it still is a rhombus. Okay, now, when we talked about note card 79, note card 79 had a bunch of ways of proving that something was a parallelogram. So my next question is this a parallelogram? Certainly looks like it, right? What are you thinking, though? Yeah, based on the appearance of it, or based on something else?
I mean, you kind of have like the same reasoning as a rhombus.
Okay, good. So what I'm trying to get at is, a rhombus, it turns out, is a parallelogram. But I want us to know for sure why it is. And on note card 79, there were four ways to prove that something is a parallelogram. But it's been a while. It was last Thursday. Yeah. Good. So one way of proving that a four-sided figure is a parallelogram is to measure this side and to measure this side. And if they're congruent, then you have one pair of congruent sides. And then also measure this side and measure this side. And if they're congruent, then you have two pair of congruent sides. And one of the ways to prove that something's a parallelogram is to show that it has two pair of congruent sides that are opposite. Okay, so that's happening here, right? This side is congruent to that side, and this side is congruent to that side. So this figure has two pair of opposite sides that are congruent, so that proves that it's a parallelogram. So a rhombus is a parallelogram. So that means that everything on note card 78 that talks about what happens with parallelograms is going to be true for rhombuses also. Opposite angles are going to be congruent. Diagonals are going to bisect each other. Consecutive angles are going to add up to 180. So a rhombus is a parallelogram. So everything that's true about parallelograms is going to be true for rhombuses as well. But there are a couple things that are true for just rhombuses. Actually, I think the correct plural is rhombi. So there's a couple of things that are true for all rhombi. First one is the diagonals of a rhombus are perpendicular. The diagonals of a rhombus are perpendicular. So let me draw another rhombus over here. It's not very good, but anyway. So here's the first diagonal, right? Then here's the second diagonal. And on a rhombus, this angle in here is 90. That doesn't happen with regular old parallelograms. Doesn't happen with regular old rectangles. So that's something special about rhombi. When you draw in the diagonals, they hit at a 90-degree angle. Okay, another thing that's true about rhombi is the diagonals bisect the angle. The diagonals of a rhombus bisect the angles. So what I mean by that is, if this angle here was 60 degrees to start out, then when this line comes through here, it makes this angle 30 and also that angle 30. So the 60 degrees at the corner there got split exactly in half by that diagonal. That doesn't happen on just regular old parallelograms. But on a rhombus, both of those are equal. And same thing up here. These are going to be equal. Same thing over here. These are going to be equal. And same thing down here. These are going to be equal. So on a rhombus, the diagonals cut the angles in half. That doesn't happen on other figures. Okay, so I've been talking about what happens with rhombuses, all the stuff that happens. But sometimes we don't know if it's a rhombus, and so we're going to have to investigate to see if it is. So here's a theorem that talks about how to tell if a figure is a rhombus. If a quadrilateral so a four-sided figure is a parallelogram, and it also has perpendicular diagonals, if a quadrilateral is a parallelogram and it also has perpendicular diagonals, then it turns out it's a rhombus. So if you have a four-sided figure and you're trying to figure out if it's a rhombus, first you have to show it's a parallelogram. And we learned a bunch of ways of showing that something's a parallelogram. And then you'd have to check the diagonals and see if they were perpendicular. And if both of those things checked out, it was a parallelogram and the diagonals were perpendicular, then you would know it was a rhombus. So that's how you tell if something's a rhombus. Okay, one more vocabulary word. Square. I know you already know what a square is, but I'm going to say it in a different way than you've heard before. I'm going to tell you what a square is. It's a quadrilateral That's not surprising. It's a four-sided figure. That is both a rhombus and a rectangle. A square is quadrilateral. That is both a rhombus and a rectangle. Now, when I say it's a rhombus, what am I saying? What is a rhombus? Yeah.
Quadrilateral with all four sides congruent.
Okay, good. So when I'm saying it's a rhombus, I'm saying that all four sides are equal. So I could have written with all sides equal, but I just used the fancy word rhombus. It means the same thing. And then when I say it's a rectangle, what am I saying? Yes, sir, Charlie?
The quad with four right angles.
So I'm saying it has four right angles when I say rectangle. So I could have, here's the definition you've heard before. A square is a quadrilateral that has four equal sides and four right angles. I said that, I just said it in a different way. I said four equal sides, but I used the word rhombus. And I said four right angles, but I've used the word rectangle. It means the same thing, I'm just using the new vocabulary words to get you used to them. So that's what a square is. Okay, the hole punch is in the back, I think, so if you punch and then send it forward. So in our neighborhood, the garbage truck comes on Thursday morning. Did you know that they go to different neighborhoods on different mornings? Maybe you didn't know that, but anyway. In our neighborhood, they come on Thursday morning. So we have to put the garbage can out on Wednesday night, right? Because sometimes it's really early. Sometimes the garbage truck comes at 5 and wakes you up, right? So we put the garbage out on Wednesday night. And then Thursday morning, before our kids got on the bus, and we're not there when our kids get on the bus, right? Because those elementary kids, they're lucky they get to start at a reasonable time, 9 o'clock. We have to be here at 7:30, which is crazy, right? So our kids get on the bus after Mrs. Early and I are already here at school. You with me? So my middle kid is very helpful. So last Thursday morning, I put the garbage out on Wednesday night, but he, on Thursday morning, said to his grandma, who helps get him on the bus since Mrs. Early and I are here, right? Said to his grandma, hey, can I bring the garbage can back into the garage? Because he was being helpful, right? So he brought it back in. Well, I got home, and the garbage can was still full. So he was being helpful. He brought the garbage can in, but unfortunately, he brought it back in before the garbage truck had even been there. So this week, it kind of smells in our house because, no, I'm kidding, it's in the garage. But anyway, we still have last week's garbage. Yeah, I know. But I can't really be upset at him, right? Because he was trying to help. You would have thought that he would have noticed how heavy it was, but anyway. So this is Geometry 6-4. So there's a picture of this four-sided figure, and the directions say that it's a rhombus. So we know that this is a rhombus. And number 1 says that SP is 4x minus 3, so that means I could go over here and label that as 4x minus 3. And then it also says that PQ is 18 plus X. So I could come over here and label that as 18 plus X. And then, of course, it says figure out what X is. So how are we going to do that? Okay, it is true that we can make them equal to each other. But it's not a good reason that we should just set them equal to each other because they both have X in them. We need a more solid reason for that. So yeah, go ahead. No, that's not true either. Like, so I could draw a figure that went from A to P, and then from P to Q. And that just because they both have P doesn't mean that this is going to equal that. You with me?
Yeah.
All right. So you're doing great. You would have gotten this question right because you would have set them equal to each other, but we need a reason for doing that. Yeah.
They're quadrilaterals, so, or parallelograms, so all sides are equal, so we can set one side equal to the other.
You're really close. On a parallelogram, it may not be true that this side equals this side.
So because they're quadrilaterals.
On all four-sided figures, it may not be true that this side equals this side.
Because they're a rhombus.
Good. Now, okay, finally, good. Awesome. Because this is a rhombus, right? The directions said it was a rhombus. And since it's a rhombus, that means that all four sides are equal. And so that means that this equals this. All right, thank you for putting up with me. I really appreciate it. Because that's annoying when I keep saying, no, that's not a good reason. No, that's not a good reason. No, that's not a good reason. Yeah. All right, so we're going to subtract x over. So 3x minus 3 equals 18. And we're going to add 3 to both sides. So x comes out to 7. Number 2 is talking about an angle. Sure. The angle it's talking about is PRS. So let me draw this line in here. So angle PRS. So trace from P to R to S. So that gives us this angle here. So there's PRS. And apparently that's 17 degrees. That's what they're telling us. Okay, now the question is, what is the measure of angle QRS? So we got to figure out QRS. That's this whole thing. The rotation from here to there. So how big is QRS? Mm-hmm. 34, good, because this is a rhombus, and on a rhombus, the diagonal cuts the angle in half. So if that was originally 34, and this cut it in half, then both of them are 17. So that's coming from this fact right here. The diagonals of a rhombus bisect the angles. Okay, I'm going to move on to number 4. You just need one line for number 3. It's a one number answer. It'll be easy. So leave a space for 3. This is number 4. Number 4. So now this picture's getting kind of cluttered, so I'm going to get rid of some of this stuff. The other diagonal here is drawn in. and this point here is called point T. And we have the information that ST is 13. So that means from S to T is 13. 13 centimeters or whatever. So now we're going to try to figure out how far it is from T to Q. So how far is it from T to Q? Yeah, 13 is correct. But more importantly, how do we know that this is equal to this? Yes?
It's perpendicular, so isn't that the midpoint?
Yeah, you are correct, it's perpendicular. Because on a rhombus, there's a 90-degree angle there. But I could draw a couple of perpendicular lines where this would not be the midpoint. So that was great thinking. You are correct that this is a 90-degree angle, but you're not correct that just because it's 90, that will mean that this will equal this.
And it bisects the angles.
It does bisect the angles, but this is talking about the side. Yeah, you're fine. You're fine. You don't have to get it right. Because you had a really good thought about the fact that that was 90. So focus on that, right? Now, how do we know that both of these are 13? This line is called a diagonal, right? And it is getting sliced in half. Does that happen? What kind of figures does that happen with? Yeah.
Wouldn't it just be definition of bisect? Since the line PR is bisecting SQ, it makes the sides equal.
Yeah, you're right, but how do we know that PR bisects SQ? Because over here, we didn't have that information, right? We had the angles getting bisected, but we didn't have the diagonals getting bisected. Okay, Charlie, good.
It's because of T.
There's a point in there, but that doesn't mean it has to be in the middle. You're doing great, though. Yes?
Because of parallelogram.
Okay, because this is a parallelogram. Every rhombus is a parallelogram, right? And on all parallelograms, the diagonals cut each other in half. So that's why they're both 13. Good. All right, for number 7, now we're going to move to number 7, and there's some points to graph on number 7. So you need an x-axis and a y-axis. You guys are doing great. Thank you for trying to follow my logic on a Monday morning. So we got x-axis, y-axis. The first point is negative 7, 3. The second point is negative 2, 3. And there's 1, 7. And negative 4, 7. So negative 2, 3 is point E. Negative 7, 3 is point D. Negative 4, 7 is G. And 1, 7 is F. part A of this problem was to just graph the points. All right, for part B, we're going to find the distance from D to G. Now I'm a little bit upset at myself for saying the word distance, because this means find the distance, right? So I should have asked you, what does this mean? Okay, so how am I going to find the distance from D to G? Yeah, distance formula. So that really fun formula. So then you do y minus y, so 7 minus 3, and square it, plus -4 minus -7 squared. And that equals distance squared. So with distance formula, you subtract the y's, 7 and 3, and you subtract the x's, -4 and -7. Then you square them up and add them up. Okay, so 7 minus 3 is 4, so that's 4 squared. -4 minus -7 is 3, so that's 3 squared. Then 4 squared is 16, 3 squared is 9. 16 plus 9 is 25. Take the square root. So distance comes out to 5. So if I were going to measure this with a ruler, it would be 5 centimeters. The distance from there to there. All right, then part C. Well, I'm going to do part C later. Leave some space. I'm going to move on to part D. It says FG. For FG, I don't want to use the distance formula because I want to avoid that if I can, because it's a pain, right? So for FG, I'm just going to count how many spaces there are. Now it's hard if you didn't have graph paper, but do you see how it's 1, 2, 3, 4, 5 spaces straight across? Okay, so that was easy. And then for part E, we're going to do the same thing. It wants to know how far it is from D to E. So we're going to count that also. 1, 2, 3, 4, 5. So it's 5 across from D to E as well. So here's what's happening so far. We did the distance formula to find that, and it was 5. We counted this, and it was 5. We counted this, and it was 5. So I'm starting to think that this might be a rhombus. Because so far, we have 3 equal sides, right? So now we got to check this last one and see if it's also 5. And if it's also 5, then we'll know that this figure is a rhombus. But unfortunately, for this one, it's slanted, so I'm going to have to do distance formula. I can't count. So that's why I left that one for last, because I knew we were going to have to do the formula again. Okay, so that's 7 minus 3, and then 1 minus -2. Seven minus 3 is 4. 1 minus -2 is 3. And 16 plus 9. 16 plus 9 is 25. 25 square rooted is 5, so it came out to 5, which you shouldn't be surprised. So part F says, what does all of that tell us? Well, it tells us that quadrilateral D F E D. Yeah. I can do this. D G F E. Supposed to go around when you name it. D G F E is a rhombus. All right, we're getting close. So part G says this. What is this asking for? When you got a little M in front of it. Yeah, Taylor? Unfortunately, it doesn't stand for measure. Now, that is confusing because when you have the M in front of the angle, it does stand for measure or amount. But this symbol already stands for measure or length or amount, right? So here the M doesn't stand for measure. It's kind of bad that they made that choice. Yeah, Jennifer?
Slope.
Stands for the slope of the line. So how slanty it is. Okay, so we want the slope from F to D. Slope formula is a lot easier than the distance formula, so I'm happy about that. So we're still going to subtract 7 minus 3. 1 minus negative 7. You still subtract the y's and subtract the x's, but this time we're just going to make a fraction out of it. That's how slope works. So it's 4 over 8, which reduces to 1/2. And then part H asks for the slope of EG. So this line so 7 minus 3, negative 4 minus negative 2. So minus 3 is 4. Negative 4 minus negative 2 is negative 2. That divides out to negative 2. So what's going on with these two slopes? Yeah.
The opposite reciprocal.
They're the opposite reciprocal. The reason they're opposite is one of them's negative, one of them's positive. The reason they're reciprocal is they're flipped. 1 over 2 would flip to 2 over 1, and that's 2. So these slopes are opposite reciprocal. What happens with lines that have opposite reciprocal slopes? Maybe not. They're perpendicular, meaning they hit at a 90-degree angle. And that goes back to the picture that I showed Rachel. You could be perpendicular without being equal, right? Like this line. Good. Okay, so this means that the lines are perpendicular. So FD is perpendicular to EG. Does that surprise you? That this line is perpendicular to that line? Why not? Because I told you that on a rhombus, the diagonals would be perpendicular, right? That's one of the things we wrote down on today's note card. So they should have had opposite reciprocal slopes.